Do you remember where you had those tedious tables where you had a series of x values, let's say ranging from -4 up to +4, and you had equivalent y values, and you had to plot them on a graph, and some were missing, and you had to say what the missing ones were, etc., etc. In this tutorial, we're going to be looking at straight lines, but we're going to be looking at them from a much cleverer point of view than those tables. We're going to deal with their gradient and where they intercept with the y-axis, in other words, the vertical axis. So going back to the table, let's for a moment assume for every value of x, y just copies it. So if x goes up from -4 to 4 in lumps of 1, so does y. So what could be the equation that represents those facts? Y must equal x. So any input value of x we can think of, 20, 47, -56, y will match. So to plot the points of a line that's represented by the equation y equals x, it's not so very difficult. If x equals 1, y equals 1. So here's a plot point. If x is 2, y is 2. And you can see we're drawing a line which will go through all these points on the grid. That's the equation I've got loaded into this bit of software already. The software is called GeoGebra, and I strongly recommend you download it, and indeed this application, which I've designed for GCSE use, to display such functions. If I click on Show Red, it will draw the graph of y equals x. And as you can see, it goes through our points really rather well. So let's get rid of those points. We don't need them anymore. We can stick with our curve. Now you can see it does have a slope. And in mathematics, we don't tend to use the word slope. We tend to use the word gradient. But what kind of gradient is it? Well, our definition of gradient is this. We read left to right. And if you were walking along this line left to right, you'd be climbing. And gradients are defined to be positive if, as you move from left to right, you have to climb. So a line sloping downwards has a negative gradient. So let's draw a steeper line. Again, start from 0, but as we go along 1, we climb 2. So that will be our first point. Our next point, go along 1 and climb 2. Go along 1 and climb 2. Now in the negative direction, go back 1 and drop 2. Go back 1 and drop 2. Go back 1 and drop 2. You can see that we've formed another straight line just by using that rule, along 1, climb 2, along 1, climb 2. Well, this has also been programmed into our software here, and I can display it by just clicking on Show Blue. And it's actually given us the equation. It says that the equation representing this blue line is y is equal to 2x. Well, let's just try it. Let's say we are at x is equal to 2. So y must be equal to 2 times 2, which is 4. So if we go up, yes, that's true. Okay, let x be -3. X is -3 in here. -3 times 2 is -6. So let's have a look. Yeah, -6. So the number before the x in here and here, there is a number here. It's just that we don't write it. It's the number 1. So we've got two lines here of two different gradients. They're both positive gradients, yes. But how would we measure the gradient from the lines we're given? Let's choose 2 points on the red line. Let's choose that point and that point. What's the gradient of that line? Well, gradient is defined by how much we climb divided by how much we go along. So if we travel from, let's call that A and that B, if we travel from A to B, we've climbed 1, 2. So this length is 2. And we've gone along 1, 2. So this length is also 2. So the gradient in this case is equal to 2, the rise, over 2. So gradient defined as the rise divided by, well, go along is too complicated a term to use. Instead, we use the word run. So the gradient is the rise over the run. That's a useful thing to remember. Okay, what's the gradient of the blue line? Well, let's choose 2 more points. Let's go from there to there. Let's call that A and that B again. Our rise will be this distance here, and our run will be this distance here. Our rise is 1, 2, 3, 4, and our run is 1, 2. So the gradient, which remember is rise divided by the run, which in this case for the blue line is equal to 4 over 2, which is equal to 2. Well, there's the 2. And for the red line, we had the gradient of 1, and in there is simply 1. So the coefficient of x in any straight line equation starting like y equals gives us the gradient. And if you didn't know that number, or if it was given a letter and you had to work it out, well, you just measure the rise and the run between 2 points, divide the rise by the run, and you'll get an answer. Okay, I've cleared the decks and drawn another line. Now, what's the gradient of this line? Well, the best way to do it is to draw 2 points. Doesn't matter where they are. Let's choose this one here. And a nice point, well, let's choose that one down there. A good long way. Well, the rise is all of that, and the run is all of that. So counting up, 1, 2, 3, 4, 5, 6, 7, 8. This is 8 tall, and this is 1, 2, 3, 4. If we say this is A and this is B, and we're doing the journey from A to B, effectively our rise is not a rise at all, it's a fall, or a rise of -8. And our run, well, our run is still positive because we're going the way we read and we're going from left to right. So that's okay. So this is 1, 2, 3, 4. 4. -8 divided by 4 is -2. So this line here has a gradient of -2. And that's what this software has just confirmed. The equation for that line is y is equal to -2x. And the points should work out again. If x was -3, -3 multiplied by -2 is +6. 1, 2, 3, 6. Yes, it does. The line goes through the coordinate point -3, 6. Let's just compare that with the line y equals x again. Once more, the gradient of this line is 1, and the gradient of the blue line is -2. It's just a negative number multiplying the x.